I'm going to finish Our Mysterious Universe today. I'm going to be on the right on page 27 under the Big Bang and Other Mysteries. When astronomers developed ways to measure how far galaxies are from Earth, they discovered that the light from these distant places looked more red than expected. This red shift was measured by Edwin Hubble and showed that the objects being observed were moving farther away from our own galaxy. In other words, the universe was actually expanding. Hubble spent years observing distant galaxies and collecting data about how quickly they were moving away. He was able to plot and graph and show the rate at which the universe is expanding. Since he knew the speed of the expansion, he was able to estimate how long ago all matter in space was in a single spot. That is the point of when it all began. Today we know that the universe began more than 13 billion years ago. On page 27, there's a picture of Edwin Hubble. He lived from 1889 to 1953. How the universe began. The Big Bang Theory states that everything in the universe was created from a tiny fireball that exploded into being and began expanding rapidly. For hundreds of thousands of years, the fireball was too hot for matter to exist in the form of atoms. Instead, particles that make up matter interacted. As the universe expanded and cooled, atoms could eventually form. These atoms were not spread evenly throughout the universe. There were slightly denser patches here and there. These patches would eventually form the galaxies, stars, solar systems, and Earth. We do not know exactly what happened at the moment the universe was created. There are many hypotheses, however, that use current data and technology to explain what could have happened. Underneath the black and orange picture, the caption says, "Subatomic particles like those created in the hot, dense, and hectic conditions of the young universe can be studied in instruments called particle accelerators." The caption for the blue picture on page 28 says, "In a fraction of a second after the Big Bang, the universe expanded in size 100 trillion times." Whoa. Page 29. Evidence for Big Bang. Most astronomers believe the Big Bang best explains all available observations. They continue to discover data to support the theory. They use tools such as the Hubble Space Telescope as time machines to look at galaxies and other objects 12 billion years old or older. Using temperature-detecting radio telescopes and satellites, scientists have discovered a faint and constant hiss caused by background radiation spread throughout the universe. They believe this hiss is what's left from the heat of the Big Bang. The caption to the top picture says, "This picture, taken by the Hubble Space Telescope, shows some of the most distant objects we can see at this time. Some of them are more than 12 billion light years away." The caption to the pink and blue image says, "This satellite image, made in 1992, shows that background radiation left over from the Big Bang was not evenly spread through the universe. These irregularities in background radiation give clues about how galaxies were formed. The red patch shows where radiation is most dense." The fate of the universe. Today, astronomers are trying to determine what will happen to the universe. If it continues to expand forever, the galaxies will drift farther apart. The stars in the galaxies will eventually die. Even the black holes will cease to exist. Our cold, dark universe will be home to a huge number of subatomic particles separated by vast distances. This is called the open universe theory. If enough mass is in the universe, gravity will counteract its expansion. The universe will then collapse on itself in a big crunch. All matter will come together in a single point. The end of our universe might also be the start of a new universe, one that could follow entirely different laws of nature from those we currently experience. This is called the closed universe theory. Astronomers are trying to measure the mass of the universe to find out how it will end. All visible objects, galaxies, stars, gas, dust, and planets don't contain enough mass with enough gravitational pull to collapse the universe. What we see in space is only part of what's actually there. Scientists have discovered that most of the matter in the universe is dark matter, material that doesn't give off any light. Astronomers know dark matter exists because its gravity pulls on stars and other visible matter. I'm going to look at the big picture first and read those in order. I'm going to read the top one, open universe, first, and then closed universe. So both of them start with galaxies use up their gas and dust, no new stars are formed. Then the second part says supermassive black holes form in centers of dying galaxies. Number 3, supermassive black holes disappear, leaving only white dwarfs and neutron stars. Number 4, white dwarfs and neutron stars collapse, forming new black holes that soon disappear. And number 5, the expanding universe becomes cold and contains scattered subatomic particles. Now, the closed universe starts again with galaxies use up their gas and dust, no new stars are formed. But the second step says that the stars and galaxies begin to die, the universe stops expanding. Step 3, each galaxy is now a supermassive black hole surrounded by the remains of stars. The universe contracts and the galaxies move closer together. Step 4, the remains of the stars boil away into space as the background temperature increases. Galaxies merge. Step 5, supermassive black holes merge. Atoms break up into subatomic particles. And step 6, universe disappears into single mega black hole, the Big Crunch. The black caption box, text box there says missing matter. The missing dark matter may come in several forms. One possibility is something called MACO, which stands for Massive Compact Halo Object. MACOs include dim brown dwarf stars and possibly tiny black holes. Another possibility could be a WIMP, or subatomic weakly interacting massive particle. Some scientists suspect WIMPs exist everywhere and could make up 90% of the matter in the universe. These scientists are working on developing equipment and experiments to detect WIMPs. Is anybody out there? The fate of the universe is the only area scientists are exploring. Astronomers are also trying to determine the structure of the universe. Other scientists are trying to find the laws of physics that govern the way the tiniest particles, as well as the largest galaxies, behave. Scientists are also researching whether life exists on planets other than Earth. As far as we know, Earth is the only place in the universe with life. However, the elements needed for life, carbon, hydrogen, and oxygen, are common in space. Sun-like stars with planets revolving around them have been discovered in the Milky Way. Billions of galaxies are also in the universe, each of which could contain stars with solar systems. Could there be any intelligent life in these galaxies? The caption underneath that creature says, different conditions on other planets might produce creatures like this artist's idea. Scientists are looking into the possibility of life on other planets. The search for extraterrestrial intelligence is often called SETI. Radio telescopes are used to listen for signs of life and to send signals from Earth into space. Some of these telescopes can be used to scan the skies 24 hours a day, listening for communications from alien sources. Others are used to study radiation from stars and nebulae. South of Arecibo, Puerto Rico, is a huge radio telescope more than 1,000 feet wide. It has a 50-acre surface to collect messages. Scientists from all over the world use the telescope. In 1974, some of them sent a message into outer space using the telescope's radio transmitters. The message consisted of a series of on and off pulses aimed directly at a globular cluster of stars. It will take 23,000 years for the message to reach its destination. If there's ever a reply, it will take that long for a message to come back. The caption at the top of page 33 says, the world's largest single-dish radio telescope, the Arecibo dish, is built in a natural hollow in the hills of Puerto Rico. Radio telescopes like this are used to listen for communication from other worlds. Looking closer to home. Obviously, distances in space make the search for extraterrestrial life challenging. With the technology currently available to scientists, it would take tens of thousands of years for people to travel from Earth to Alpha Centauri, the nearest star to the Sun. It takes 4.3 years for a message traveling at the speed of light to reach there from Earth. Scientists are also looking for life within our own solar system. Some of the planets can be ruled out. Mercury and Venus are probably too hot. Uranus and Neptune are probably too cold. However, scientists wonder about Mars. Could it ever have been inhabited? The caption above that picture says, some scientists think it's possible that microorganisms exist in the Martian soil. Because Mars lacks a protective atmosphere, lethal radiation from the sun bathes the Martian landscape, making surface life unlikely. Space probes began exploring Mars in the 1960s. Since then, more robotic spacecraft had followed. They have collected soil samples and taken pictures. From these, we have learned that Mars once had water on its surface and an atmosphere. We know it has volcanoes larger than anything on Earth and ice caps at both of its poles. Scientists continue to study its soil. They also study meteorites believed to be from Mars that fell to Earth thousands of years ago. One such meteorite was thought to contain tiny structures, possibly ancient fossils of primitive life. The caption under the top picture says, the Viking space probe photographed long Martian channels that may have once held running water. The black text box says, colonizing Mars. Perhaps someday we could change the environment on Mars so that life from Earth could survive there. It might take centuries, but if we could find a way of releasing the carbon dioxide that is trapped in the Martian surface, plants would be able to grow and eventually an oxygen atmosphere would develop on Mars. Could humans follow? Some say it's possible. On Mars, there are giant mirrors orbiting Mars might someday be used to melt carbon dioxide trapped in the Martian ice caps and rocks. The moons of Saturn and Jupiter also interest astronomers. Titan, Saturn's largest moon, has an atmosphere with a high percentage of nitrogen, similar to Earth's. The Galileo space probe has sent back pictures of Europa, one of Jupiter's moons, showing massive ice floes, or sheets of ice. Scientists wonder if a huge ocean exists beneath the floes. These moons are so far away from the sun that the temperatures should be well below those considered necessary for life. Volcanic activity, or the gravitational influence of Jupiter, however, could make them warm enough for supporting living things. The caption under the planet there says it's possible that simple aquatic life may exist on Europa if there are oceans under its frozen surface. And the caption above the picture on page 36 says, space probes, as shown here in this artist's rendering, will help scientists to discover whether Titan could support life. What's next? Over the centuries, our understanding of the universe has greatly expanded. Many questions have been answered, but many more have been raised. Our present technology allows us to observe distant objects from incredibly tiny subparticles to galaxies near the edge of the visible universe. We have not yet reached the limit of our understanding of the universe. 1,000 years ago, many people believed they understood the universe, with Earth at the center of everything. Now we believe we have a more accurate picture of the universe, with Earth positioned in one spiral arm of one galaxy in a universe with no center. What will we discover about our mysterious universe in the next 1,000 years? The caption there says, we still have much to discover about the universe. Go try those questions. Good luck.